Hello everyone, so let's start the important topic, that is the improved definition of carbohydrate. So here we are going to take a look at the example of glucose, the open chain structure. As I told you in a previous video that open chain structure is thermodynamically unstable. So what's going to happen there, it's going to invert into this cyclic form, and how it interconverts into the cyclic form, let me show you, and then I'm going to define the improved definition of carbohydrate. Okay, so first of all, what happens is that for example, this is the open chain structure of glucose. Here I'm going to take the example of glucose. So this is the chemical structure of glucose. Chemical structure of glucose. So I'm going to write down, let's say glucose. Glucose. Okay. So this structure is thermodynamically unstable. Okay. So what happens is that it becomes thermodynamically stable and it interconverts into the cyclic form. Okay. So what happens is that over here some reaction takes place. So this particular oxygen connected to the carbon number 1, the aldehyde, oxygen of the aldehyde, this is thermodynamically, this is not, I mean, like, this open chain is thermodynamically unstable, but this oxygen in the aldehyde of this glucose is electronegative. So what's going to happen is that it's going to take this electron present inside the single bond, and there will be the development of partial negative charge, and there will be development of partial positive charge on this carbon, and there will be development of partial negative charge on this oxygen. Okay, so since there is a partial positive charge on this carbon, so what will happen, the oxygen inside this hydroxy connected to the carbon number 5th will perform a nucleophilic attack on this carbon with partial positive charge. A nucleophilic attack occurs when an electron-rich species attacks on the electron-deficient species, So this is a kind of nucleophilic attack when this oxygen inside this hydroxy connected to the carbon number 5th is going to attack on this carbon number 1 with partial positive charge. And this hydrogen is going to perform the electrophilic attack on this oxygen with the partial negative charge. Okay, with the partial negative charge on it, and it's going to be a kind of electrophilic attack. That means when an electron deficient species attacks on the electron rich species. So here electron deficient species will be hydrogen and electron rich will be oxygen with this partial negative charge. So this kind of chemical reaction takes place, and this is the mechanism of this chemical reaction. So what happens because of this kind of chemical reaction, that this open chain form of glucose interconverts into this cyclic form. And what kind of cyclic form is that, let me tell you. Okay, so this particular as a result of this particular chemical reaction between this particular alcohol, this particular hydroxy connected to the carbon number 5, that means this whole alcohol and this aldehyde, so because of this particular chemical reaction, what happens is that formation of the cyclic form takes place. It's a kind of cyclic form, and this cyclic form is called as internal hemiacetal. Internal hemiacetal, internal hemiacetal. Now here the question is come, what is the meaning of hemiacetal? So as you know that alcohol and aldehyde. Alcohol and aldehyde are reacting with each other. So when an alcohol and aldehyde reacts with each other, the formation of hemiacetal takes place. So what is hemiacetal? That when an alcohol, for example like ROH, and an aldehyde RCHO, for example, say this is ROH is the alcohol and this R1CHO is aldehyde. So this is alcohol and this is aldehyde. So when an alcohol and aldehyde reacts with each other, the formation of hemiacetal takes place. So how hemiacetal looks like? Hemiacetal looks like this. This is hemiacetal. This is hemiacetal. So if you will see inside of the hemiacetal, this is the central carbon, and if you will consider, this is the central carbon inside of this internal hemiacetal form of glucose. And with this hemiacetal over here, OH is connected, and with this inside of this hemiacetal with this central carbon, OH is connected, and inside of this glucose cyclic form with this carbon, OH is connected. Okay, and in hemiacetal with this carbon, hydrogen is connected, and here also inside of this cyclic form of glucose with this carbon, hydrogen is connected. And inside of hemiacetal with this central carbon, R1 is connected. R1 is a kind of carbon chain. So this particular with this central carbon, you can say that this is R1, and OR is connected with the central carbon in the hemiacetal. So here with this particular central carbon, OR is connected. You can say OR is connected. OR is connected. Okay. So this whole, this hemiacetal resembles this particular hemiacetals, because whatever is connected to the central carbon is also connected to this particular carbon inside of the cyclic form of glucose. So you can say that this is also a hemiacetal, but it's an internal hemiacetal inside of the glucose. Okay. So since aldehyde and alcohol react with each other, the formation of hemiacetal takes place. The same thing is happening over here also, that inside the open chain of glucose, aldehyde and alcohol is reacting with each other to form internal hemiacetal. And this particular structure with the internal hemiacetal is cyclic in nature. So I'm going to write down it's cyclic, cyclic, and this structure is thermodynamically stable. So this is thermodynamically stable. That means it exists in its lower energy state. So it's thermodynamically stable. So here in this cyclic form of internal hemiacetal, you cannot see aldehyde anymore. You cannot see aldehyde. There are hydroxys, and this central carbon is over there. So what happened to the aldehyde? That aldehyde has interconverted into the hemiacetal form. It reacted with the alcohol and it converted into the hemiacetal form. And this structure is thermodynamically stable. So over here, in the light of this particular example, so I can write down in the light of above example, we can say that carbohydrates are polyhydroxyaldehyde, aldehyde, polyhydroxyaldehyde, or we can better say that polyhydroxy compound, polyhydroxy compound, polyhydroxy compounds with aldehyde function present, either free or as hemiacetal. So you have to remember one thing over here, that it's a polyhydroxy compound. Why it's a polyhydroxy compound? Because there are so many hydroxys connected to this with aldehyde function present. That means it has aldehyde. Definitely it has aldehyde function present, either free or as hemiacetal. So as I have written over here, as I have told you over here, that the open chain form of glucose is thermodynamically unstable. Being thermodynamically unstable doesn't mean that it will not exist at all. It will definitely exist, but at a very very low extent, at a very low percentage. For example, like you can say 0.1%. Inside of the aqueous solution of glucose, you can say that the existence of open chain form is 0.1%. That means very low. That means we can also say that aldehyde function present if it is open chain, but even at a low extent, that means aldehyde is free. That means aldehyde function present either free, but maximum or as hemiacetal. As you can already see, it will react with, it will combine with the hydroxy or the alcohol, you can say, or the hydroxy connected to the carbon number 5 to form thermodynamically stable internal hemiacetal form. So we can say that either free or as hemiacetal, or hemiacetal or acetal. Here you will have to remember hemiacetal, but also as acetal. So you will see that what is acetal. Acetal, when hemiacetal, when this particular hemiacetal, when this particular hemiacetal, when this particular hemiacetal reacts with alcohol, then the formation of acetal takes place. For example, I would say, when the hemiacetal, this is hemiacetal, R1 OR OH, yes, this is hemiacetal. When this hemiacetal will react with alcohol, let's say alcohol will be plus R2OH. So this is alcohol. So when a hemiacetal react with the alcohol, the formation of the formation of acetal takes place. Actually, when a hemiacetal and alcohol react with each other, the formation of acetal takes place. And how this acetal actually looks like? This acetal is going to look like something like that: R1 OR H and O R2. As a result of this particular reaction, a water molecule also comes out. Water molecule also comes out, because what happens is that this hydrogen combines with the OH and water molecules comes out. So when a hemiacetal and alcohol reacts, the formation of acetal takes place. So this kind of a structure is called as acetal. And later, when I will talk about oligosaccharides, you will see that inside of the oligosaccharide you will find this kind of acetal structure. For example, here in the cyclic form of glucose, you are finding hemiacetal ring So internal hemiacetal you are finding. So inside of oligosaccharides, a class of carbohydrate, you are going to find acetal. That's why I have written over here that either free or as hemiacetal or acetal. Hemiacetal inside of these simple sugars like these monosaccharides like glucose. Acetal in some higher classes of carbohydrate, you will find acetal is also found over there. So you can definitely say that polyhydroxy compound with aldehyde function present either free or as hemiacetal or acetal. So in the light of the above example, and the above example is of glucose, if I would take fructose over here, then you would see the formation of hemiketal over there. So I'm going to take the example of fructose right now. So fructose is going to be something like that. Yeah, so this is fructose. So this structure of this open chain structure of fructose is thermodynamically unstable. So here what happens is that uh, this as you know that this particular oxygen is electronegative, so it's going to take the electron percentage as a single bond, and the partial negative charge will develop and the partial positive charge will develop on this carbon, partial negative charge will develop on this oxygen. So this particular hydroxy oxygen having oxygen inside of this hydroxy connected to the carbon number fifth will perform the nucleophilic attack on this carbon, and this hydrogen will perform the electrophilic attack on this oxygen with partial negative charge. So here either the hydroxy connected to the carbon number fifth or either the hydroxy connected to the carbon number sixth can take part in the reaction. You will see in later videos about pyranose and furanose form of fructose, but here I'm gonna take the hydroxy or the alcohol with carbon number fifth. Okay, and oxygen or ketone is present with carbon number 2. So as a result of this reaction, what's going to happen is that the formation of internal hemiketal takes place. So how the internal hemiketal actually looks like, it looks like something like that. So this is called as internal hemiketal. And this internal hemiketal form is thermodynamically stable. Thermodynamically stable. Okay, so this is thermodynamically stable. So how this is internal hemiketal? So hemiketal formation takes place when alcohol reacts with the ketone. So let's see the formation of hemiketal actually. So I'm gonna say suppose R1OH. This is gonna react with ketone. So ketone is gonna be something like that. CO, and with this CO, R2 and R3 is connected, suppose. So this is alcohol actually, and this is ketone. When alcohol and ketone is going to react with each other, the formation of hemiketal will take place. So hemiketal something looks like that. With this R2 and OH will get connected, and then R3 will get connected and OR1 will get connected. So this is called as hemiketal. hemiketal. So as you can see inside of hemiketal, with this central carbon, OH is connected and R2 is connected. And here inside of this internal hemiketal form of fructose, with this particular, with this particular carbon, OH is connected, and this particular carbon chain is called as R2. This particular carbon chain is called as R2. So R2 is connected, and then with this central carbon over here, R3 is connected. So you can say that this one is this carbon chain is R3. Okay, this carbon chain is this particular carbon. Let's say this particular carbon chain with connected H and OH is R3, and or the whole of them you can call it R3, or this OR1, this OR1. So this whole, with this central carbon inside of the internal hemiketal form, this particular thing is OR3. Okay, OR1, not OR3, OR1. OR1. So definitely this hemiketal is internal hemiketal over here, Okay, so you can also say that hemiketal is also present, it's a polyhydroxy compound with internal hemiketal form, or also as ketal. And in the next class, if we will talk about the types of carbohydrate, we are going to see a higher class of carbohydrates where we are going to find ketal kind of a structure also, and ketal forms when this hemiketal reacts with alcohol, then the formation of ketal takes place. So anyway, you will have to remember that hemiketal is also found inside of the carbohydrate, ketal is also found inside of the carbohydrate, hemiacetal is found inside of the carbohydrate, and acetal is also found inside of the carbohydrate. So we take a look at the example of open chain of glucose and then internal hemiacetal, and in the light of the above example we have said it's a polyhydroxy compound with aldehyde function present, either free or as hemiacetal or acetal. Hemiacetal we can clearly see over here, and acetal we will see in next videos, where we will see that this hemiacetal reacts with the alcohol. Alcohol will be present inside of the another carbohydrate also, when two carbohydrates will react with each other and the acetal will form. So I hope this point is clear right now. So this is the improved definition of carbohydrate.